Today we're going to start our new lesson on graphing exponential functions. So when we graph, let's start off with our parent function where our base is larger than 1. So we're going to be graphing f of x equals 2 to the power of x. So let's get a couple of points. So let's start over here. We know 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0, anything to the power of 0 is just 1. 2 to the power of negative 1, negative exponent means it's 1 over 2 to the power of 1, so this is 1/2. And then 2 to the power of negative 2 is really 1 over 2 squared, which is 1/4. So these are the points I'm going to be plotting on my graph. So negative 2, 1/4, which is just a little bit above 0. Negative 1, 1/2. 0, 1. 1, 2. And 2, 4. And we're going to connect these to draw my parent function for my exponential graph. So, looking at this graph, there is clearly a domain, it goes left and right forever, of all real numbers. The range, however, it starts at 0 and goes up. So your range is 0 to infinity. Doesn't include the 0 because it never touches the 0. The reason being, there's an asymptote right here. So the asymptote is at the line y equals 0. So there is an asymptote here. I'm going to draw it using a different color so you can see. It's a dotted line here at x is equal to y is equal to 0. So characteristics here, this is a 1-to-1 function because it passes both the vertical and the horizontal line test. It is increasing the entire way, so it's increasing from negative infinity to infinity. And there's no x-intercepts, but there is a y-intercept at 0, 1. So y-intercept is at 0, 1. So what you should notice about all exponential graphs, every single exponential function is going to go through the point 0, 1 and 1, b. Because anything to the 0 power is 1, and anything to the first power is itself. So no matter what the base is, you're always going to go through those 2 points. Okay, we're going to do the same thing now, but instead of having a base of 2, we're not going to have a base of 1/2. So same idea, we're going to plot these points, negative 2, negative 1, 0, 1, 2, but this time we have 1/2. So if we do 1/2 to the negative 2, now what happens is the negative means we're flipping this, so now it's 2 over 1, which is just really 2 squared. 2 squared is just 4. Again, 1/2 to the negative 1, we flip it, it becomes 2 to the first power, which is 2. Anything to the 0 power is 1. And then 1/2 to the first power is just itself, 1/2. 1/2 squared is 1 over 4. So notice what's happened here is now they've just switched places. So now negative 2 is at 4. Negative 1 is at 2, 0, 1, 1/2. And 1/4, and again when we connect our points, this is going to go towards the asymptote, this is going to go up, and we have another asymptote, dot dot dot, at y equals 0. So our domain is the same, it's all real numbers because it goes left to right. Our range again starts at our asymptote, which is 0 to infinity because it goes up forever. Our asymptote is still at y equals 0. So this one is very similar. The only difference is instead of increasing, this one is decreasing the entire time from negative infinity to infinity. So when you have a fraction here, all that's really happened are these have switched places. So at 1, it's now a fraction. At negative 1, it's now a whole number. Okay, let's take a look at some graphs now. So we're going to use this, our parent function, and the transformations from before to graph some function. So let's start off with 3. So for this one, our base here is 5. So unlike what we just did where we had a base of 2, this is now 5. So let's use this to plot our parent function point. So negative 2, negative 1, 0, 1, 2. So here's my x and my y. Okay. So anything to the 0 power is 1, right? 5 to the first power is 5. 5 to the second power is 25. All right, so these are the points. To the negative 1 means now it's going to be 1 over 5 and then 1 over 25. So this is my parent function. So I have a point at 0, 1, 1, 5, and then 225 is off the graph, so I'm not even going to see that. On this side, it's going to get smaller and smaller because they're fractions, again approaching my asymptote. Okay, so this is what my parent function is going to look like. What I'm going to do now is look at my shift. So what direction has it moved? So this is affecting my x. So x minus 2. This means that I'm moving to the right 2, because this is inside of the exponent. Outside the exponent is plus 4, so what direction is that? It's moving up 4. So I'm going to take all my points and move them right 2 and up 4. So I'm going to start off with my asymptote. So I know my asymptote before was at y equals 0. If I move it up 4, now I have an asymptote at y equals 4. And if I move this point right 2, 1, 2, up 4, 1, 2, 3, 4. Here's my new point. This one goes right 2, up 4, 1, 2, 3, 4. Here's my new point. I'm going to connect them and then approach my asymptote. So my graph here looks like this. And it's approaching the asymptote. So this is my f of x, the transform function. So it's this one that's been shifted to the right 2 and up 4. So my domain is still all real numbers. My range, however, starts at 4 and goes to infinity because I have an asymptote at y equals 4. So this dotted line right here is my asymptote. Okay, let's look at another problem for number 4. So again, we're going to start off with our 1/3 because this is our b. So this is going to help us draw our parent function. So if I have -2, -1, 0, 1, and 2, these are my x's. Anything to the 0 power is still 1. That's always 1. 1/3 to the first power is 1/3. 1/3 squared is going to give me 1 over 9. And when it's a negative exponent, now it's going to flip. So this is now going to be 3 and 9. So here are my initial points, my parent function points. So let me start off plotting this. -2, 9. -1, 3, 0, 1, and then again our fractions, which means that I get closer and closer to my asymptote. So this is my parent function, and now I'm going to be shifting it. So I'm moving, plus 4 is affecting my x. I'm going to go left 4, -2 means I'm going down 2 because that's outside, so it's affecting my y. So all my points are getting moved left 4, down 2. So again, I'm going to first start off with my asymptote, just like before. So this line is going to move down 2. So this is my new asymptote. For all my points, they're going to move to the left 1, 2, 3, 4, down 2. This one moves to the left 1, 2, 3, 4, down 2. And left 1, 2, 3, 4, down 2. And again, I'm going to connect them all and approach the asymptote. So this is my new function, f of x. Domain, all real numbers. Range starts at, my asymptote is at -2. So -2 to infinity, because it still goes up. My asymptote is at y equals -2. Okay, let's flip to the back. We're going to do a couple more examples. So for number 5, so again, we're going to start off with our base. This is a base of 2. So my parent function is, again, 0 to the is always going to give me 1. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And now the negative exponents are going to be fractions. So my parent function is 0, 1, 1, 2, 2, 4. And then approaches the asymptote at y equals 0. Okay, so now let's look at our transformation. So we have a negative x and this -3. So this negative x means that it's a reflection across. If you're changing your x from negative to positive, it's a y-axis reflection. The -3 means I'm moving down 3. So let's first reflect this across the y-axis. Here's the y-axis. What this means is this point is going to be reflected over here. This one is going to be reflected right here. And it's now going to be pointing in this direction. So it's been reflected across the y-axis. And now all my points are just going to move down 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, including my asymptote, which also moves down 3. And I'm going to connect all these points, approach the asymptote, and this is my f of x. Again, domain, all real numbers. My range starts at the asymptote, which is -3 to infinity. My asymptote is y equals -3. Let's do one more graphing. So my b value here is 4. So for my parent function, again, 0 to anything to the 0 power is always 1, so this is 1. 4 to the first power is 4. 4 squared is 16. If we go to the negative exponents, that's 1 over 4, 1 over 16. So this is my parent function. So fraction, 0, 1, 1, 4, 2, 16 is off the graph, so I actually can't see this one. So this is just going to approach my asymptote again. So here's my parent function. There's a couple different things that are happening here. This minus is on the outside, which means it affects my y. If it's a negative y, this means it's being reflected across the x-axis. There's also been a shift. Plus 3 affects my x, which means I'm moving to the left 3. Plus 2 affects my y, means I'm moving up 2. So the first thing I want to do is my x-axis reflection. So if it reflects across the x-axis, now it's going to, this point is going to be down here. This point is going to be down here. It's still approaching my asymptote. So now, if it reflects, it's now pointing down instead of up. And all of my points are going to move to the left 3 and up 2. So first of all, my asymptote moves up 2. So now it's up here. All my points move left 3. So 1, 2, 3, up 2. And this one also moves 1, 2, 3, up 2. Connect those points. Approach the asymptote. And this is my f of x. Again, all real numbers is my domain. My range is a little bit different because this is the first one that's pointing down instead of up. So if it's pointing down, this is a negative infinity to 2. And my asymptote is y equals 2. Okay, let's finish up with writing my functions for these following graphs. So I have f of x equals. So I have my 2 points right here. Let me first start off by drawing my asymptote. So here is my asymptote. If this is my asymptote, this tells me that my point, this is 0, 1. So if this is 0, 1, my next point is 1, 1, 2, 3, 4, 5. So 0, 1, 1, 5. This tells me that this value right here is my b. So this is 5 to the something power. And this is the starting point right here, because it's at 0, 1. So really this is moved from my origin left 6, up 2. So if it's left 6, this is going to be plus 6. Up 2 means up to plus 2. This is my equation. So same idea for this one. Let's first start off by drawing my asymptote. And then, so this is really the starting point, because again, this is 0, 1. If this is 0, 1, in this case, this is actually negative 1, 1, 2, 3. If this is negative 1, 3, that means 1 would be 1 over 3. So in this case, my b value is 1/3. Again, let's see how far this has shifted. It's moved 4 to the right, down 5. 4 to the right means this is going to be x minus 4. Down 5 means this is going to be a minus 5 on the outside. And this is my equation for this one.